We'll begin our study of the chapter on logic by defining some terms, and the first of these is the idea of, or the definition of something called a statement or a logical statement. For us, a statement or logical statement will be a declarative sentence that is either true or false, but not both at the same time. For example, I ate spinach for lunch today. Declarative sentence says that I did something, and that action is either true or false. It can't be both at the same time. The second, 5 plus 8 is equal to 10. Declarative statement, declarative sentence is saying that 5 plus 8 is equal to 10. That happens to be false, but statements can be true or false, just not both at the same time. So that's a perfectly good statement. So what are some things that are not statements? Well, I'll name a few. If I say hit the baseball, that is not something that you can say that's either true or false. It's a request or a command. I can't judge it as true or false. If you responded and said, I will hit the baseball, that would be a statement, and I can judge it as either true or false. But a command or a request is never a logical statement. Are you listening? Even easier. That's a question. Question is never going to be a logical statement because it's not declarative. It's questioning something. The third example is just a sentence fragment. It just says, if I were a rich man. It's not even a complete thought. Not a statement. The last one is a little more interesting. It says, this sentence is false. If you think about it a minute, it sounds like a perfectly good statement, except how are you going to judge it as being true or false? If you assume the statement is true and you read it, the sentence itself says it's false. So by assuming it's true, you're supposed to believe that it's false. That's a logical fallacy. And if you assume the sentence is false, then since it says it's false, you'd have to assume that it's true. Again, a logical fallacy. You get into this situation of a paradox. So you're never going to take something that on the face of it looks like it could be a statement. And if you get into a logical fallacy, some kind of paradox, you cannot think of that as a mathematical statement. Now let's move along and talk about the idea of a compound statement. If you have simple statements and you connect them together with what we call connectives, you get a compound statement. We'll have 5 connectives that we'll talk about. I've listed 4 of them there: and, or, not, if, then. The 5th one is, and we'll talk about it more later, is if and only if. But these connectives stick simple statements together to form compound statements. So, for instance, Dickens wrote novels and the poem is short. Well, obviously Dickens wrote novels is a perfectly good simple statement. The poem is short is a perfectly good simple statement. And they're joined together with one of our connectives. So that is a compound statement. Moving along, you can pay me now, perfectly good simple statement. You can pay me later, perfectly good simple statement, joined together by another one of our connectives. So that's a perfectly good compound statement. The third one, have to explain a little bit. You think of this as the base statement as being today is payday. We're not going to go into the details. We're only overviewing this chapter on logic. We're not delving very deeply, but just leave it to me to say that when you change what is obviously a simple statement, like today is payday, into a negation by adding a not, that is considered to be changing it from a simple to a compound statement. Don't worry too much about why, because we're not delving deeply enough into this to go there. But just remember that not changes it to a compound statement. And of course the last one is using the if-then connector. Today is Wednesday is a perfectly good statement. I have math class is a perfectly good statement. And they are joined together by this connective called if-then. So these are just some straightforward examples of compound statements. One of the things we'll spend quite a bit of time on is talking about the negation of a statement. In the simplest cases, you'll just put the word not in, or if the not's already in there, you'll take the word not out. The negation of a statement is basically going to always change the truth value to its opposite. So if the statement were true, the negation would be false. If the negation were true, the original statement would be false. So examples of some statements and their negations. If I said the Earth is a planet, the negation would simply be the Earth is not a planet. If I said today is not Tuesday, the negation would be today is Tuesday. So adding or subtracting a not in the simplest cases is how you form a negation. It's not always that simple, especially if you're working with compound statements. So before we go to that, though, I want to make this a little more mathematical. Suppose I had the statement x is less than 7, and I ask you what the negation was. A lot of people say, well, it would be x is greater than 7. That is not correct because you're not putting the number 7 in either place. If you take a statement and its negation, you've taken care of everything, every possibility. So if I say the statement is x is less than 7, and you say it's x is greater than 7, you've left out 7. Where does 7 fit? 7 itself is not in there, and 7 itself is not in there. So that can't be the negation. So the punchline here is that, and let me get rid of some of this so you can see it better. The punchline is if you have an inequality in a statement and you want to form the negation, if it doesn't have an or equal to in the original statement, the or equal to has to go in the negation. So the negation of x is less than 7 is x is greater than or equal to 7. Now if it were reversed and you had the equal to in the original statement, then the negation would not have the equal to. So does that make sense? You have to cover everything. Everything has to be included in either the statement or the negation. So especially with these less thans or greater thans, there's going to be an equal to in one place or the other, but not both. So as I said, the negation of x is less than 7 is x is greater than or equal to 7. I mentioned that we're going to formalize more the connectors that we're going to use. So this is probably as good a time as any to do that. We're actually going to be using 5 different connectives or connectors, however you want to say it. And we will have symbols for those and names for those. So this is a good time to just go ahead and be explicit about that. We've talked about some of these. The first connective, and, the symbol for it is an inverted V, and it's called a conjunction. The second connective is an or, and you can see I've put inclusive in parentheses. This is called the inclusive or. The symbol for it is a V shape, and it's called a disjunction. Now there is also an exclusive or. We're not covering it here, but there is one, and the basic difference is whether if you put or between two statements, the truth value of that statement with an or in it is different for an inclusive and an exclusive in one case, and I'll get more into that later. But just remember that the only or we'll be using in this course is the inclusive one. The third connective is not, and we have that tilde symbol, the little squiggle, and it's called a negation. If then is a right pointing arrow, and it's called an implication. And if and only if, which is a double-headed arrow, and it's called a biconditional. Now what some of these mean, we'll get more into detail. I just want to present the connectives that we'll be using and their symbols and names. And as we go through this, we'll talk more about exactly what they mean and their truth values, of course. Start off simple. If I have a symbolic statement where each letter, P and Q in this case, represents some statement in common English, then I can translate that symbolic statement into a statement in English. So for example, if I say P and Q, I simply put the and in the middle, the statement P on the left, and the statement Q on the right. So what I have, of course, is the statement P going here, the statement Q going here, and the symbol for and tells me that I just write the word and. So that's how it works. Very simple. Similarly, if I do the negation of P, or some people would say not P, you simply take the statement P, which is the car is blue, and negate it. That'd be the car is not blue. I don't want to belabor this because I think it's pretty simple. If I have if that third line, P or Q, it's the same as P and Q except the and changed to an or, so it's still going to be using the car is blue, the dog is big, but the and changes to an or, so it's the car is blue or the dog is big. This is the most complicated one yet, but it's still not difficult. You've got the statement P, which is still the car is blue. You have an and, but now you have a negation. So you've got to think about this. You've got the negation of the statement Q. The statement Q is the dog is big. So to negate that, you'd say the dog is not big. So putting it all together, you have P, which is the car is blue, and then you negate the Q statement, making it the dog is not big. Now what if I use the implication? Remember, the right pointing arrow is the implication, or if then. So again, it's the same as the one above it, except I take the and out and put an if then connector in there. So it still uses the car is blue and the dog is not big, but I take the and out and replace it with the if then phrase. So it becomes if the car is blue, then the dog is not big. And finally, what if I take not Q, if and only if P? Remember, the double-headed arrow is the if and only if, or the biconditional. We'll talk more about exactly what that means in terms of logic, but right now we're just doing the translations. So the not Q is the dog is not big. We've done that twice now. And P is the statement the car is blue, and the connector is if and only if. So it says the dog is not big if and only if the car is blue. Just some simple translations to get you started with this. This is very important, so pay attention here. There are two big categories of quantifiers that we will be talking about, and they're extremely important when we're finding negations of statements that have quantifiers. Universal quantifiers are things like all, each, every, no, and none. It asserts that the statement being quantified is true for everything that's relevant in our universe that we're talking about. So when I say all people breathe air, it's like I'm spreading my hands out, I'm including everybody. Each, every, and no person has 10 arms. I'm including everybody in that by quantifying that way. So those are the quantifiers that spread out to the whole universe. Hence they're called universal quantifiers. For example, I could say all dogs bark, None of the drivers was hurt. Each student made an A. No joke was funny. All universal. The other category goes the opposite way. Existential quantifiers assert that the statement being quantified is true for some subset of things, for at least one thing, but not necessarily everything. So I could use words like some, there exists, at least one, things like that. Some kids are kind, at least one score was a touchdown. There exists a UA student who doesn't like football. They're narrowing things down. So whereas with the universal quantifiers, I was kind of spreading my arms and saying everybody is included. Now I'm honing in. I'm taking a subset and saying that there's a subset, or there's at least one, with this characteristic. So you have to think about those. They're easy once you think about what they mean. Knowing this is going to be helpful in finding the negation of statements that have these quantifiers in them. So let's actually just try an example. Before we do, I want to mention what I'm calling here a helpful hint, and that is if you're negating a statement with a universal quantifier in it, the negation will be an existential statement, and vice versa. If you're negating an existential statement, the negation will be a universal statement. So that sort of helps you get started when you're negating a statement with a quantifier. Let's do a couple of simple examples. If I say all athletes are wealthy, and I want to negate it, so the second column is for the negation. The first thing I'm going to do is realize that I've got to change the all to some or something like that, because if I start out with all in the original statement, the negation's got to come from the second line. So you're going to pick something from the second line, and I've got some here. And the other thing you've got to think about is what really negates it. If the original statement is claiming that all athletes are wealthy, if I want to negate that, I have to come up with at least one person who is not, that's an athlete who's not wealthy. So I decided that it should have a sum because it had to be something from this second category down here, and then I decided that if this is wealthy, if they're saying all athletes are wealthy, I've got to come up with some, or at least one, athlete who is not wealthy. So that's kind of the game you're playing here. The all gets changed to something from the second row in the existential quantifiers, and the fact that I want to negate that statement, I know I need to find some non-wealthy athletes, and that's where I come up with the second part. Let's try another one. This time let's start off with a sum. Some students get loans. Now that sum is down here in the existential quantifiers. So what I'm going to come up with on the other side is one of the ones from the top. Now I want to also choose the one that sounds best in English, and I'm not saying there's a unique answer, because there's not, but I want to choose an answer that sounds best as in common English. There are different ways of saying things sometimes with these formal logical statements that sound very stilted, but I'm going to do my best to try to pick one of them that makes it sound better. So here's what I chose, and I'm going to defend it here. I know it started out with some, so whatever I put over here has to come from the other group, one of the universals. Now I chose no, and after we read it out, I'll just want to, I hope you'll agree that it sounds really best in just common English. Now so if I've chosen my quantifier, I want to now finish the rest of the sentence. You got to think about what this thing is saying. The original statement is claiming that some students get loans. So if I want to negate that, and I've chosen no as my quantifier, how would I show that that statement is not true? Or how I'd negate that statement? I would have to, if they're saying some students get loans, I would have to contend that no student gets a loan. That would, if I found one student that got a loan, then the fact that some students get loans would be true. So if I'm trying to negate that statement, and I'm going to use no, then I've got to assert that no student gets a loan. So there are stages to this process. Sometimes you can just match up words. Like I know some is going to have one of the top quantifiers, and if I'm one of the top quantifiers, like all, it's going to have some or one of the others. That part's easy. But the rest of it, you got to think, what does it take to really negate that statement? And that's not necessarily so easy at first. So I would suggest you practice until it becomes sort of second nature. But the first step is to realize that you switch categories of quantifiers when you do a negation. And then you just think it through after that and figure out what would it take to make that statement negated.